So what does it take to create an oil and gas field? Well, there are three essential components to be aware of. The first is that there must be a source rock, and the source rock must be rich in hydrocarbons and buried deep enough so that the heat from the Earth's core can cook them into oil and gas. This is usually a fine-grained shale rich in organic matter. Second, oil and gas need to be able to move, to migrate upwards through tiny connected pore spaces in the rocks. If the pores in the rocks are interconnected, then oil can flow easily out of the rock. This parameter is known as permeability. The porous rock must have good permeability so that the oil or gas can migrate into the permeable layers known as the reservoir. And the third essential component is a trap. And a trap is needed to capture the oil and gas. This is sometimes referred to as a caprock or seal, as it traps the oil in the underground reservoirs and prevents them from escaping to the surface. Now, it's important to remember that these reservoirs of oil and gas are not underground pools of oil, but porous and permeable rocks that can hold significant amounts of oil and gas in their pore spaces. And the hydrocarbons are mixed with water and sand, and they gradually seep through the porous layers of sandstone or limestone, two common sedimentary rock types in which oil and gas are found. Now, sandstone is composed mainly of sand-sized minerals. Most sandstone is composed of quartz and or feldspar because these are the most common minerals in the Earth's crust. Like sand, sandstone may be any color, but the most common colors are tan, brown, yellow, and red. Now, limestone is a rock that's formed by the accumulation of shells, bones, and other calcium-rich goods. It's composed of calcite, chemically known as CaCO3, and typically the color of limestone is white. Now, as we mentioned before, once the oil and gas reach a layer of impervious rock, they are trapped and an oil and gas field is created. Now, what we know is that the Earth has a geothermal gradient. That temperature increases as we go from the Earth's surface and under the crust, and the gradient is typically 30 degrees Celsius per kilometer. At about 60 degrees Celsius, organic rich material known as kerogen decomposes and breaks down to form oil. So what we have is an oil window, a temperature dependent interval in the subsurface where oil is generated. And this oil window is often found in the 60 to 120 degrees Celsius interval at about 2 to 4 kilometers in depth. Now, at higher temperatures, we have the gas window, which is found in the 100 to 200 degrees plus Celsius interval at about 3 to 6 kilometers depth. Now, in general, deeper deposits contain mainly natural gas, in most cases pure methane.